What's going on, guys? Let's do this problem right here. This question is asking a long solid cylinder of radius 2 feet and length 5 feet is hinged at point A, is used as an automatic gate. When the water level reached 15 feet, the cylinder gate opens by turning about the hinge at point A. Determine the hydraulic force acting on the cylinder. So hydraulic acting on the cylinder and line of action, and also the weight of the cylinder. So let's see how we can find it. So first of all, they are asking to find the hydrostatic force acting on the cylinder. So let's see how we can do this. So first of all, I am taking this part right here. This part and drawing separately, because that's what's gonna give us the hydrostatic force. So if I draw this part, this look like something like this. Okay, so we have this part right here, and so there we are going to have a force that is exerted by the cylinder on the water. So that is going to be the value that's where we are going to find. That's called, let's say, Fr, and this is going to be coming from the middle of this cylinder. So this is going to be it, and this will make an angle with vertical. So that's going to be, let's say, that's phi. And that's the second question, is line of action when the gate opens. So that this is what we had to find for the second question, and this is all the information we have. And let's see how we can find it. So first of all, we know that in the cylinder we are going to have force that exerted by water, like this distributed force. It's all going to be parallel to this cylinder. So that's going to be same right here. So in the outside of this one, this thing, so we are going to have force, distributed force exerting like this. So this is going to be something like this, and let's say this one as F horizontal and this is F vertical. Also we are going to have two components for this one, horizontal component for this one, this is vertical component FRV, and horizontal component FRH. But the main thing is this one right here. This is what we have to find, and that's all the information. So let's create an equation. So if I take summation of f of x, also we are going to have the weight of the water, W. So that's another force. Now if we take the forces on the x-axis, we are going to have Fh in the positive direction. Let's say this is positive, so Fh in the positive direction, reaction for this force exerted by cylinder on the water has horizontal component, that's in the negative direction, FRH, and that is equal to 0 in equilibrium, and therefore FH is equal to FRH and FV. So let's take the vertical forces. So if I take sigma FV in this direction, upper direction positive, we are going to have FV positive, and also we are going to have FRV negative, and then we have the weight right here, that's going to be negative W. So this is going to be FV minus W is going to be FRV. So why do we need these things, FRH and FRV? Because FR is going to be equal to square root of FRH square because we are taking the component of the r fr, right? So if we calculate this one, this will give us fr square plus frv square, and that gives us the fr. That's the question for the first one, right? So let's see. So if we go further, we have horizontal force that's equal to frh, and let's see how we can find the horizontal force. Horizontal force can be calculated by the average force that is acting on this one. So the average force can be calculated by the pressure acting on the centroid. So we know this 2 feet length because the radius of the circle is 2 feet. So we know this length is going to be 2 feet too, and the centroid is going to be 1 feet because it's going to be exactly in the middle. And from the top, if you take this reference points, from here to here it's 14 feet. So 14 feet. So that's the height we are going to take to calculate the pressure acting on the centroid. So pressure can be defined as rho gh. So rho is going to be water density, that's 1000 kilogram per meter cube, time 9.81, acceleration due to gravity 9.81 gram per no meter per second square. And if I calculate this value, this gives us 9180 Newton per meter. Yeah, this is the value we get, but in this case we are measuring everything in foot, so we have to convert this one into foot for pounds and foot. So let's do this. So if I convert this one into pound per foot cube, this gives us 62.4 pounds force per foot cube. So this is what we are going to use instead of, so let's put up the equation first. So we have rho g h at the centroid for the pressure. First, fh is equal to p times a, p times a, p, let's say pc, pressure at centroid, times the area. So in this case, area is going to be what? 2 times, so we know this is 2, and they have given the inside length 5. So the area is going to be 2 times 5. So yeah, 2 times 5. So let's put area first. Area and rho g. So rho g value is going to be this one, 62.44 foot force per feet cube. So 62.4 times the height of the centroid, that's going to be 14 feet. Let's put the units. So this is foot force per feet cube times 14 feet times the area is going to be 2 times 5. And if I calculate this value, this one comes out to be 8736 foot force. So this is the answer for this is horizontal force, and that gives us FRH, because we know that FH is equal to FRH. So this is equal to 8736 foot force, pound force, and we have to calculate the FRV right now. So to calculate that one, I have to calculate FE, vertical force, and the W. So let's calculate the vertical force first. So it's going to be same equation, rho g HCA. So rho g is going to be same thing for this one, that is 62.4, and for the centroid, so this is horizontal centroid. For the vertical centroid is going to be, so let's put it in this picture. Centroid is right here, for this one it's right here, but it's going to be 15 feet from the reference point. right? So that's going to be the height. So this is 15 times 15 feet times the area is going to be same thing, 2 times 5. And if I calculate this one comes out to be 9360. But to calculate the FRV we need the weight also, weight of this water right here. So this weight of the water, what I can do, okay, if I calculate total weight and deduct this weight of the cylinder, that gives us the weight of the water, right? So I'm taking this point right here, this one. So in this case what I can do, so weight equation, weight is going to be mg m is equal to rho v, rho times density times volume times g. So this gives us the weight. And yeah, let's substitute this one right here. So let's rho g times the volume. So in this case volume we are going to have 5r square h, that's volume of the cylinder, and this is 1/4, so 1/4 5r square h. So we have to deduct this one from, let's say we are considering this one as a cube, like a cube, right? So that is going to be length time width time height. So length time width time height minus this is total volume minus this volume of this cylinder, 1/4 of the cylinder. So that gives us the volume of this one right here. So let's calculate that one. That's going to be, first of all we know that length is going to be like this one, 5 for the cylinder, 5, same thing. So 5 multiply by 2 times 2, because the radius gives us the width and the height, that's 2 times 2, minus 1/4 of the cylinder, 1/4 times 5r square. So 5 times 2, radius is 2 square. And if I calculate the weight, we can substitute this value for rho g right here. This is rho g is equal to 62.4. And if I substitute and find the value, this gives us 268 pounds force. And now we can calculate this FRV. So FRV is equal to FV minus W. So FV is right here, 9360 minus 268, and this gives the value of so this gives the value, let me see, I have to use the calculator. Let's see, 9360 minus 268, that gives us 9092 pounds force. And we have FRV, FRH, and now we can answer the first question. So FR is going to give you the answer for the first question, so let's calculate it. FR is equal to square root of FRH square plus FRV square. And if we calculate this, if we plug these two values right here, FRV right here, FRH right here, this gives us 13,050 pounds force. So that is the answer for the first. That is the hydraulic force acting on the cylinder. And then they are asking to find its line of action when the gate opens. So now we have to find the phi right here, so that's going to give us the line of action. So to calculate the phi, what we have to do, we have this equation that tan phi is going to be equal to FRV divided by FRH. So we know both values right here, so we can simply substitute. The phi is going to be tan inverse FRV divided by FRH, and if I calculate this value, this one comes out to be, so we have the, let's put the values. Tan inverse 9092 divided by 8736, and this gives us 46 degree. So we have the tan phi. Now the final question is the weight of the cylinder. So we have to calculate the whole weight. So what I'm going to do, let's raise this one. I do this part right here. So if I draw the cylinder, first of all, let's draw the cylinder and put all the forces acting on it. So in the cylinder, we are going to have the weight right here, weight, and then we have this FR. So this direction, when we separate, this is going to be opposite. So FR right here, and then we have a, this is, since it's the hinge point, this is going to have two forces, AY and AX. And what else we have? We have resultant, this force right here, but I can write this one as two components, so that makes everything easier. So I can put it vertical component FRV, FR, let's use a different color, FRV, and FR horizontal. So we have two components right here, and that's all we have. And now we have to find the weight. So what we can do, if I take the moment around, because we have AX and AY, two unknown things, we don't even want to find this unnecessary thing, right? So we can simply eliminate by taking the moment around it. So if I take moment around A, what's happens is this will be eliminated, and we are going to have force moment created by W. That's going to be W times 2, because the radius is 2 feet, W times 2, and that's acting in the clockwise direction. So if I take counterclockwise positive, this acting in the clockwise direction, so this is going to be negative. And we have FRV in the counterclockwise direction, that's going to be positive. FRV times 2 is equal to 0, because FR, I can erase FR because I have take, oh just let's know the, so FR is divided as FRV, FRH, so we don't have to separately do this because that is this. So from this one we can say FR 2FR is equal to 2W. We can cancel 2 and 2, therefore FR W is going to be equal to FRV. W is equal to FRV. We calculated the FRV already. That's 9092 pounds full force. So that's going to be the value of the weight of the cylinder. So weight of the cylinder is equal to, let's say, WS, weight of the cylinder, so WC, weight of the cylinder, that's going to be equal to 9092 pounds force, and that is the final answer. I hope you guys liked this video. See you next time.